Chapter 72, Introduction to the Arithmetic of Complex Numbers. Solve x squared plus 1, which is equal to 0. Then x is plus or minus the square root of negative 1. We've already seen that the square root of negative 1 is not a real number. So it is not what we call a real number. So why do we expand this? Why do we expand the system of numbers we are used to? We are giving the expanded system the name of imaginary numbers, or complex numbers, and refer to the square root of negative 1 as I. We combine an imaginary number like 2i with a real number like 3 to create a complex number like z, which is 3 plus 2i. Note that 2 plus 3i and 2 minus 3i are called complex conjugates. Just like we had 2 plus square root of 3 and 2 minus square root of 3, which were called conjugates. A historical note: an imaginary number is a number whose square is negative. When any real number is squared, the result is never negative. Imaginary numbers have the form bi, where b is a non-zero real number, and I is the imaginary unit defined by I squared, which is negative 1. I is the square root of negative 1. I squared is negative 1. Now the term imaginary does not mean it's a figment of your imagination, it's just a term. An imaginary number bi is called a real number to form a complex number in the form a plus bi, where a and b are called respectively the real part and the imaginary part of the complex number. Imaginary numbers can therefore be thought of as complex numbers where the real part is 0 and vice versa. And the name imaginary number was originally coined in the 17th century as a derogatory term, as such numbers were regarded as fictitious or useless, but today they have essential concrete application in a variety of scientific, engineering, and related areas. Look at Wikipedia, imaginary numbers, and you'll see some interesting things. Real numbers are now a subset of complex numbers. For instance, 5 can be written as 5 plus 0i. I squared is negative 1. I cubed is I squared times I, so negative I. I to the 4th is I squared squared, negative 1 squared, positive 1. And then we start the cycle again. I to the 5 is like I to the 6th is like I squared, I to the 7 is like I cubed, and I to the 8 is like I squared, and so on, and so on. What is I to the 251st power? Well, first of all, it's I to the 4 to the 62, which is probably 248, plus 3. So I to the 3rd power, 62 plus 3. 62 times 4 plus 3. So 1 to the 62nd power, which is just 1, times I cubed, which is negative I. Note that in the last example, you can divide 252 by 4 to get a remainder of 3. So I to the 251, I to the 254, that's a misprint, is I cubed. We will do arithmetic of complex numbers using z sub 1, which is 3 plus 5i, and z sub 2, which is negative 4 minus 6i.